Okay, so I just started recording. Sorry. So if you're watching this, if we're going to find the area using 3 points, it's a lot of work to do it geometrically by hand and distance formula and perpendiculars. But what's nice is somebody somewhere, somehow, I have no idea, figured out that you can actually use matrices to find the area of this triangle without doing all of that work. I don't know who the person was. They didn't give it a name, but it's going to make it so much nicer. And it's with determinants. So if you have a triangle, then you don't ever have to draw it. You just need the 3 points. The formula is 1/2. So there's still a half in it. And you take your 3 points, you take your X of your first point, the Y of your first point, and then 1 is the third. And it's always a 1 in the third one. Then you take the second point, Y of the second point, 1. You take the third point, the Y of the third point, 1. And when you put that in the calculator, you will get the area of that triangle. So numerically, it would be 1/2, and then it's 2, 8, 1, 5, 1, 1, 9, 10, 1. So over in Desmos, I'm going to do a new matrix. You want a 3 by 3. You want 2, 8, 1, 5, 1, 1. All right. And the other one was 2, 8, 1, 5, 1, 1, 9, 10, 1. So 9, 10, 1. Put that in, and then you're going to do 1/2, or you can do 0.5 if you want, 1/2 times the determinant of that matrix. Now, if so, the area of that triangle, if we would do all that work, is 27.5 units squared. So this triangle, if we would have done it the other way, we would have got 27.5. And it doesn't say what the measurement is, so you just say U squared for area, for units, whatever. And that's it. So this is one of the best things about Well, but this is a really convenient use of matrices instead of doing all that work. So let me show you that again. Now, if you're doing this, if I line up these points different, sometimes your determinant will come out to be a negative number. So just always take the absolute value. If it's negative, that's fine. Just change it to positive. So simply for your homework, you're going to have problems where you have 3 vertices and it's 1/2 and it doesn't matter the order. So 5, 7, 1, -8, 12, 1, 1, -9, 1. So if I go to Desmos, if I do new matrix, doesn't matter what the name of the matrix is, 3 by 3, and it was 5, 7, 1, 5, 7, 1, -8, 12, -8, 12, 1, and 1, -9, 1. All right, so once you put in the matrix, make sure you're paying attention to the name of it. 1/2, don't forget the half of the determinant of that matrix. So it's 114 is the whole area. Now, if I did, let's see if this -8, that one, 12, and this one would be the 5, 7, is that right? negative 8, 12, and 5, 7. Yeah, so if I switch those and now I do 1/2 of the determinant of B, see how it comes out negative 114? So if that's the case, that's fine. Just remember that the answer is going to be positive for area. So depending on how you order them, sometimes it might come out to be negative. No big deal. The answer is 114. That's it. So one more example, real quick. So the determinant, it'd be 1/2. Remember, determinants, that's straight up and down line. Negative 8, negative 5, 1, negative 2, 4, 1, 4, 13, 1. So, oh wait, am I here? Sorry. Okay, so this was find the area, those 3 points. So put them into the matrix, followed by ones. Go to Desmos. I'm going to clear all. So when I do new matrix, I'm back to an A matrix. And it was negative 8, negative 5, negative 8, negative 5, 1, negative 2, 4, 1, and 4, 13, 1. 4, 13, 1. 1/2 of the determinant of that matrix is 0. So how in the world could a triangle have an area of 0? Doesn't make any sense. Right? So the answer is 0. That's a beautiful 0. The answer is 0. Right, so what's going on here? If you look graphically, you look at these points, then negative 8, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, negative 8, negative 5, negative 2, 1, 2, 3, 4, and 4, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Those 3 points don't make a triangle. They're aligned. So that's why the area is 0, because it's not even a triangle. So if you get a problem where the area is 0, it just means those 3 lines are collinear. So that's another useful thing in that if you were ever asked, are these points collinear? You don't have to graph it. You don't have to find the slope and stuff like that. You can just put them into that matrix, and if it's the determinant 0, then they are 3 collinear points. All right. So there is an assignment. Like I said, I'm going to go ahead and stop that recording.